Welcome back, Leo Lions. This is Mrs. Morgan, and today's lesson is going to be about cube roots. Notice in Shobi, under this lesson, there are two documents, and we'll get to that other one, but it's going to just be a complete list of all of your perfect cube roots. So first, I apologize, I did it once, so there we go. I included some things on here, and then you'll be able to copy them down, but I'm going to start up here at the top first. Everything in purple is what I'm going to be talking about with square roots. So square roots, we actually talked about last week, and we did squares and square roots. So I want to talk about why we call them squares and square roots. So up here in the corner on your notes, I want you to draw a square. So a square, we know, has all the same side measurements. So let's take, for instance, that this is a side, or a square with side lengths of 6. So if we wanted to find the area of this square, remember area is everything inside of here, all of that space. So to find area, and I'm going to take that away so we can actually read it, we do side times side. So we do 6 times 6, and that would give us 36, and whatever the unit is, feet, inches, centimeters, whatever, let's say inches squared. So that's all that space inside of there. So that's why we call it squaring a number. We take that number multiplied by itself, and that's area. Okay, now the opposite, we did square roots last week, so let's draw another square up here. Let's say instead of actually knowing the side lengths, well, in this square we know that the area is, let's say, 64 units squared, or inches squared. Well, we do it the opposite way, and we try and figure out, okay, well, what number times itself gives us 64? So we're taking the square root, so we know that x is 8 inches. Okay, so that's why we call them squares and square roots, because it all has to do with a two-dimensional shape, a square. Okay, now today we're going to be talking about cube roots, and cube roots come from our picture over here, a cube, and we're going to be talking about volume of a cube, and that's why we call these cube and cube roots. So in a cube, let's say we know all the side measurements. This first example is going to be 2, so we know all of these side lengths all around the cube is 2. Okay, and even all of those side lengths in the back of this that we can't see on the cube. So let's say we have a cube with side lengths of 2 units. To find the volume of a cube, we will find the product means multiply, of 3 of its side lengths. So of 2 and 2 and 2. We do length times width times height to find volume. Okay, remember, so area was all that space on the two-dimensional. Volume is everything. If we were to fill this up, let's say we start filling this with water, okay, and how much water can we fit in this entire cube? Well, that's what we call volume. Okay, so length times width times height, 3 times, that's cubed, so that's why we call them cube roots. Okay, so another way to write 2 times 2 times 2, that is the same thing as 2 cubed. Okay, and remember, off to the side here, I'm going to put 2 times 2 times 2, the exact same thing. Okay, and so 2 to the 3rd power means 2 cubed. Okay, notice that we are dealing with cubes here, and that's where, like I told you, we get that term cubed. Okay, now let's say we know the volume of, and let's actually, that last problem real quick, if we were to actually find the volume of this cube off to the right, 2 times 2 times 2, so 2 times 2 is 4, and then 4 times 2, so this volume is 8 units cubed, whatever the unit would be. I'm going to scoot this over, and in this case we aren't told, so I'm just going to say 8 units cubed over here. Okay, now let's keep going. Let's say we have the volume of a cube is 64 units cubed. So to determine the volume of the cube, we need to determine what the number cubed equals. So what number cubed equals 64? So we know 64 is the exact same thing as 4 times 4 times 4. Okay, and you may have to play around. You may not know that off the top of your head. I'm going to show you a list, and then hopefully you'll get that pattern down. But 4 times 4 is 16, and then 16 times 4 is 64. So that's how I found that. Okay, another way to write this is we're going to use a cube root symbol, which looks like this, looks just like our square root, and then there's a small little 3 in that index spot. So the cube root of 64 does equal 4. Okay, so the cube root symbol does look like that. So you can draw like a square root and then put that little 3 there. I'm gonna make my pen a little smaller. There we go. So that's what a cube root looks like. Okay, now I already wrote this down for sake of time. It says explain what the cube root symbol means. So what that means is the product, and I put a little multiplication sign above product to remind you. So the product of a number multiplied by itself 3 times is the number under the cube root. Okay, and I'll zoom out so that you can copy that down in your notes. So cube root means the product of a number multiplied by itself 3 times. So x times x times x, whatever that value would be for x. Okay, explain how the cube root is different than the square root. So again, I put up here that example in purple. The square root is a number multiplied by itself 2 times, but the difference then, a cube root is a number multiplied by itself 3 times. Okay, so if you need those definitions, you can pause the video and write those down. Okay, going on then, can you calculate the cube root of a negative number? We can't with a square, because remember, a square, and I'm going to do it in purple, if we did something like -3 times -3, well, negative times a negative is a positive. So we can't do it with squares, okay? No negatives. However, with a cube root, we can do it, and I'm going to show you, because a negative times a negative times a negative is going to be a negative. So the product, and remember again, product means multiply, of 3 negatives is a negative. And I'll show you an example. I'll continue with my example with my -3. So something like -3 times, and I'm going to put it in parentheses because it has negatives, times -3 times -3. So -3 times -3, a negative times a negative is a positive, so we'd get +9. And then +9 times -3, well, positive times a negative is a negative, so we'd get -27. So we can take cube roots of negative numbers. Okay, a cube has a volume of 8 units cubed. Explain how to determine the side length of the cube. Well, if we know the volume is 8, we have to do the opposite. So we want to calculate the cube root of 8. Okay, and I'm going to say of the volume, because maybe I tell you the volume is 343 units cubed, and you'd want to take the cube root of that. So the volume is going to change in our example. So I'm going to say calculate the cube root of the volume. So let's look at what this would look like. So to find the side, S stands for side length of this cube. We know the volume is 8, so we're going to take the cube root of 8, and the cube root of 8 is 2. So we know each side in this cube is 2 units. I figured that out because, I knew that 2 times 2 times 2 is 8. And I kind of talked about that in that example up there, up at the top. Okay, so let's look at a couple more examples. Here we have a volume of 125. So we know that it has to be x times x times x to give us 125 units, okay? Length times width times height. So we're going to take the cube root of 125. I know this one off the top of my head. If you don't, then this second document will show you all the cube roots, okay? And we could always check our work to see, does it multiply back to its volume? So 5 times 5 is 25, and 25 times 5 is 125. Okay. Next one, the volume is 1,000 units. So what times itself gives us 1,000. So we're going to take the cube root of 1,000, and that is 10. So each side length of this cube is 10 units. Again, we could check our work. 10 times 10 times 10. 10 times 10 is 100. 100 times 10 is 1,000. Okay, last example, the volume is 1. So again, same process. We're going to take the cube root of 1. 1 times 1 times 1 gives us 1. So the side length in this cube is 1 unit. And 1 times 1 times 1 is going to give us the volume of 1. Okay, so that's the definition, examples of cube roots. If you go back then to the second document, I've already written them down. I will zoom in and let you pause the video and get those first 10 written down. On the side here, I do have a helpful hint of where these perfect cubes are coming from. So it is going to help to write down this 1 times 1 times 1, 2 times 2 times 2, and so on, because that's where that number under the cube root sign is coming from. Okay, and it will help you remember that. And then I just put an arrow to help you remember. It goes on and on, even down here. Again, you can pause the video and get 11 through 20. So 11 times 11 times 11, 12 times 12 times 12, 13 times 13 times 13, and so on. Okay, once you have this complete list of cube roots, well, then you can use those to help you with our volumes and finding the side length of a cube. All right, that concludes your lesson of